How to differentiate cos of x from first principles. I wrote down a few formula that we need for this question specifically. At the very top is the double angle formula for cos A plus B. Then I wrote the small angle approximations underneath. Sine of theta goes to theta, cos of theta goes to 1 minus theta squared over 2. And then the box standard differentiating from first principles equation, f of x plus h minus f of x over h. And those are the three things that we'll need for this question. I'm going to start by writing what f of x is, and that is simply cos of x because that's what we're differentiating. And then f of x plus h would just be cos of x plus h. Then just sub those two into the formula, the basic formula for first principles. Always write your limit h to 0 on the side of each step, just so it's clear to the examiners. And then sub it in, so cos of x plus h minus cos of x all over h. If you notice, cos of x plus h looks a lot like the double angle formula for cos of a plus b. So instead of a and b, you sub in x and h. Because there's a plus goes to minus. So it will be cos x, cos h, minus sin x, sin h, minus the cos of x, all over h. Then I'm going to factorize cos of x out of the numerator, but first I'm just going to write it so you can clearly see that there's cos of x in two of the terms. So cos of x, cos h, and then I'm going to do minus cos x, and then just minus the sin x, sin h. I'm just rearranging the numerator. And that's all over h. Don't forget your limits. Limit is h to 0, just next to each working out. Now I'm going to factorize out cos of x. So cos of x bracket cos of h minus 1 minus sin x sin h on the outside. All over h. Next we're going to use small angle approximations because our limit is h tends to 0. As h gets really small, we can use the small angle approximations because theta gets really small. So whenever we see a h, we're going to just sub it in for the small angle approximation. So for cos of h, we're going to use cos of theta, so 1 minus theta squared over 2. So cos of x, 1 minus h squared over 2 minus 1, h squared instead of theta squared. The sin h just tends to h, so minus h sin x, all divided by h. Next, I'm going to simplify this bracket. 1 minus h squared over 2 minus 1. The 1's cancel out, 1 minus 1 is 0, which just leaves minus a half h squared. Now we can just sub that back in. So minus a half h squared, which was the bracket, cos of x, minus our h sin x, all over h. Now we can divide through by h. So limit h tends to 0, minus a half h cos x, minus sin x. And for our last working out, h tends to 0. As h gets really small, it goes to 0. So a half h cos x is just a half times 0 cos x minus sin x, which therefore just leaves you with minus sine x. So the differentiation of cos x using first principles is just minus sine x. So thanks for watching, hope you enjoyed.